sets, set notation, and Venn diagrams. Vocabulary and set notation. A set is a collection of well-defined objects. Objects in a set are called elements. Let's talk a little bit about sets. Sets are usually denoted with an uppercase letter and listed within brackets, also known as curly brackets. An example would look like this. A is equal to the set of integers -3, -2, 0, 1, and 4. Each individual integer is known as an element. Let's talk a little bit about elements. This mathematical phrase right here means that 0 is an element of set A. 0 is contained in set A. When I go back up here and look at set A, I notice that 0 is contained within the set. This next mathematical phrase means that 2 is not an element of set A. 2 is not contained in set A. So when I go back up here and I look at set A, I notice that 2 is not listed among these 5 numbers. So this phrase means that 2 is not an element of set A. Sets can be expressed in different forms. One type of form could be a statement. That is, a written statement that describes the set of numbers. For example, set B is defined as the first 5 counting numbers greater than 0. A second form is a roster or tabular form. That is, a list of numbers contained in a set written between curly brackets and separated by commas. An example would be B is the set of numbers 1, 2, 3, 4, and 5. The third option is set builder form. This is a description of a set that uses a rule or an algebraic formula, such as B is x, an element of natural numbers, such that x is between 1 and 5, inclusive. X is greater than or equal to 1 and less than or equal to 5. The vocabulary word we're going to look at is the word universe. Universe is denoted by these 2 symbols, the Greek letter Xi or the English letter U. The definition of universe is the set of all elements that need to be considered in the problem. This unit, we will use either one of these 2 elements. The next vocabulary word we will use is empty set. Empty set is denoted by 2 symbols. This symbol is known as null, and it is a way to show that there is a set that contains no elements. Another way is to show 2 curly brackets with nothing in between. That is referred to as the empty set. An empty set is defined as a set that contains no elements. This is an example of how we would use null in a statement. B equals null, meaning B is a set that contains no elements. The cardinal number n of a set is the number of elements contained in the set. So if A is defined to have the numbers -3, -2, 0, 1, and 4, and B is the empty set, then the cardinal number of A is 5 because there are 5 numbers, 1, 2, 3, 4, 5, and the cardinal number of B is 0 because there are no elements contained within B. Subset. This is the symbol which represents subset. We define the subset as a set is a subset of another set if all its elements are elements of a larger set. Here's an example. Let's define A as a set of natural numbers from 1 to 10. If we're using tabular or roster notation, it would look like this. A is a set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, denoted by circle A right here. If we say define B as a set of natural prime numbers less than 10, or in tabular form, B is equal to 2, 3, 4, and 5, we form a subset of B contained inside of A. So while the numbers 2, 3, 5, and 7 are in B, they also are part of A. So all the elements are part of A, so we say that B is a subset of A. Not a subset, denoted by this symbol here. It's the subset symbol with a slash through it. A set is not a subset of another set if not all of its elements are elements of the larger set. So if we define C as a set of natural odd numbers less than 10, such that C is 1, 3, 5, 7, and 9, located here in circle C, and we define B as a set of natural prime numbers less than 10. So B would be 2, 3, 5, and 7. And again, these numbers here are contained in set B. Not all the elements in B are part of C. Notice that 2 is located in B only. So we would say that B is not a subset of C. Proper subset, denoted by this symbol here. A set of elements that is part of a larger set and at least one extra element exists in the larger set is defined as a proper subset. So if we say A is a set of natural numbers from 1 to 10 and B is a set of natural prime numbers less than 10, all of the elements in B are part of A. Here's all the elements of B, 2, 3, 5, and 7. They're also part of A. A is the integers or natural numbers from 1 through 10. A contains more elements. You'll see here there are numbers that are in A, composite numbers, that are not part of B. Therefore, we say that B is a proper subset of A. A Venn diagram is a diagram that represents mathematical or logical sets using circles within an enclosed rectangle, the universal set, in this case denoted by the Greek letter xi. An example, xi is all the natural numbers from 1 to 10. C is a special set of numbers containing specifically 2, 4, and 8. And D is null, empty set. C and D are subsets of U, and D is an empty set. The cardinal number C is 3. There are 3 numbers inside of set C. And the cardinal number D is 0, since D is the empty set. Example 1 of Venn diagrams. Create a Venn diagram to illustrate the given information. Xi is a set of numbers 0 through 10. A is a specific set within that set xi, which is 0, 2, 3, and 7. And B is the set of numbers 1, 3, 7, and 10. The Venn diagram would look like this. Xi is the universe containing all of the numbers that are mentioned. A is the numbers 0, 2, 3, 7, and 9. B contains the numbers 1, 3, 7, and 10. You'll also notice that there's an overlap because 7 and 3 are both contained in both sets A and B. The numbers 4, 5, 6, and 8 are not in either set A or B, but they are contained in the universe. Example number 2 of Venn diagrams. Create a Venn diagram to illustrate the given information. The universe is xi, the numbers 0 through 10. Set A is a subset of xi and contains specifically the numbers 4, 5, and 6. Set B is also a subset of xi, the universe, and that specifically contains the numbers 7, 8, 9, and 10. The Venn diagram would look like this. Set A contains the numbers 4, 5, and 6. Set B contains the numbers 7, 8, 9, and 10, while the numbers 0, 1, 2, and 3 are in neither set, but they are out here in the universe known as xi. Example number 3 of Venn diagrams. Given the universe of xi, let's, number 1, list the elements in the universe for this problem. Number 2, name the different sets involved. 3, determine the cardinal number for A. And number 4, find the elements of a subset that is in both A and B. The answers are on the next page. So when we list the elements in the universe for this problem, xi is the numbers, or everything you see within the rectangle. -12, -3, -2, -1, 1, 3, 4, 5, 6, 7, and 17. Those are all the elements in the universe. Number 2, name the different sets involved. So here we have set A, and set A contains -3, -2, 1, and 5. This red circle here is set B, and set B contains -3, 4, 5, and 6. The cardinal number of A, or the actual number of numbers contained within the set. There are 4 numbers within set A, so the cardinal number of A is 4. Number 4, find the elements of a subset that are in both A and B. And here we see that -3 and 5 are in both A and B. So the numbers that are a subset of both A and B are -3 and 5.